Hi, everyone. My name is Kanishk Chaturvedi, and I'm a solutions architect at Software AG. And in this presentation, I would like to talk about global perspective on smart cities and IoT, where I will dive deeper into the topics of IoT and how exactly IoT is impacting various smart city use cases. So before I start, just a few words about me. So I'm based in Munich, in southern part of Germany, and I've been working with Software AG for the last 2 years, and I'm a part of its IoT and analytics business unit, and I specialize into the topics of IoT and artificial intelligence. And my education background is computer science and also geoinformation science, and I did my PhD in the area of urban digital twins. So urban digital twins is an upcoming and exciting topic in the smart cities domain. And later in my presentation, I will also talk a little bit about it. And regarding my experience, so I have in total of 12 years of work experience. And before joining Software AG, as a consultant, I worked mostly in the fields of smart cities with different European cities such as Munich, Hamburg, London, Helsinki, and so on. So yeah, as I mentioned, I'm a part of IoT and analytics business unit of Software AG, and I represent this Cumulocity IoT platform. So Cumulocity, in case you're not aware, is a leading IoT platform which has been designed to simplify and accelerate the deployment of IoT solutions. So at Cumulocity, our mission is basically to make IoT simple and fast, and it provides many advantages. So it offers, for example, robust device management capabilities, which allows users to connect and manage any device anywhere at any scale. And apart from that, this platform also features powerful analytics tools that enables real-time data processing and insights that helps organizations to make informed decisions very quickly and swiftly. And additionally, Cumulocity also provides seamless integration with third-party tools, which also enhances its adaptability and functionality. So, in a nutshell, this comprehensive integration and ease of use, it makes Cumulocity a go-to platform for making IoT implementations simple and faster. So here, the primary focus of Cumulocity is smart equipment manufacturers, such as wind turbine operators, solar panel companies. And in the later parts, I will also show you how Cumulocity is also helping realizing many smart city use cases from IoT point of view. So this was just a quick introduction about me and about the company, the product that I'm working on. And in this talk, this is the agenda that I will cover today. So we will begin with by defining what smart cities are and understanding their key characteristics. And next, we will dive deeper into IoT to see how this technology is pivotal in connecting and enhancing city operations. And then we will also explore specific IoT use cases within smart cities, illustrating how these technologies come to life in urban settings. And following that, we will also take a global tour to see examples of IoT-enabled smarter cities around the world. So we will learn from their successes and also their innovations. And lastly, we will also discuss the challenges and future trends in smart city technologies, anticipating how these technologies might shape the cities of tomorrow. So this is the overall agenda that I will cover today. And yeah, then let's start with the first question. What is a smart city? So here I would like to quote a European Commission definition because I found it really simple and easy to understand. So according to European Commission, a smart city is a place where traditional networks and services are enhanced with digital solutions. So here, according to them, the goal is basically to improve efficiency for the benefits of its inhabitants and businesses which are residing in those cities. So if we understand essentially in simple and plain language, it's basically about using a technology or set of technologies to make life better for everyone who lives and works there in that particular city. So this is a very simple definition from for smart cities, and here let's understand what are the key components. So according to me, smart city is not one single component. So smart city is basically made up of several key components that enhance urban life through technologies. So for example, smart governance. So smart governance is digital services which are improving citizen engagement and which enable efficient urban planning. Similarly, smart mobility. So, for example, intelligent systems managing traffic flow and automating public transport. It can also include smart utilities or smart grids, which respond to real-time electricity demands. Similarly, water systems or smart water systems, optimizing distribution and preventing leaks. It can also include smart manufacturing or smart infrastructures. So, for example, sensors in buildings and roads monitoring conditions, improving safety and maintenance. And yeah, similarly, smart environment. So, for example, sensors monitoring air quality and weather, which also aid in sustainable resource management. So, as I mentioned, according to me, each component here is important and its success relies on seamless integration. And how can we achieve it? So, this is usually achieved through robust digital infrastructure and also strategic decision making. So, together, these elements or these components create an efficient and sustainable urban space, which is called a smart city. So, I mentioned that key technologies are also crucial. So, let's explore the interconnected technologies that are considered the backbone or building blocks of smart cities. So, here I would list, for example, Internet of Things as top. So, Internet of Things or IoT, it allows connecting a multitude or a number of devices across the city. So, that helps or that enables them to collect and exchange real time data from different objects. So this constant flow of data is very essential for enhancing how our city operates. So for example, IoT sensors on streets monitoring traffic conditions in real time. And that basically helps or allows city authorities or traffic authorities to better understand how is the congestion, how is the traffic density at a certain junction at a particular time. The next technology is big data. So here, the data, for example, generated by IoT devices constitutes big data. So this vast amount or this huge amount of complex information that is analyzed to improve decision-making processes across various city functions. And in a nutshell, it provides the raw materials or basic materials which is needed for deeper insights and predictions. So if I continue with my traffic example, big data can include here volume, speed, and types of vehicles at different times, which also allows traffic authorities to perform or to make deeper insights to understand the patterns. The third technology I would mention is artificial intelligence, AI. So AI uses basically such big data to develop sophisticated algorithms. And these algorithms can enable predictive analytics and automated decision making. And that really helps optimizing everything from traffic systems to energy use in urban environments. So, for instance, AI can predict traffic congestion and suggest optimal routes for drivers and public transportation. That will save time, that will also save fuel, and that will be more optimal. That will also allow us optimizing or improve the efficiency of the specific city. So these are the three key technologies that are being used or already being used in smart city projects. But apart from that, there are also other technologies which are widely being used in smart city projects. So for example, digital twins. So digital twin technology creates virtual models of physical assets, such as building or entire transportation systems. So here the advantage with digital twins is that it allows us to simulate different scenarios and it allows us to manage urban infrastructures more effectively. which also enhances both planning and operation. So in the later part of my presentation, I will also give few examples of such digital twins for smart cities. And apart from that, there's also GIS, Geographic Information Systems. So GIS also provides detailed spatial analysis and mapping capabilities. So this also aids significantly in urban planning and management. And that also helps city planners to visualize spatial data and make informed decisions based on geographic insights. So, for example, using GIS technologies, city planners can create or design the detailed maps of the cities. For example, if they can map a specific street, they can label or they can create the divisions of the streets, and they can also create, for example, which lane is dedicated to which transportation mode, for example, bicycle, car, or pedestrians. So these kind of detailed maps can also be created using GIS technologies, and it also helps city authorities to perform different kinds of spatial analysis. And then in the end, cloud computing and edge computing. So these technologies also complement each other, and they are also quite crucial to handle the vast amount of data generated by a smart cities. So for example, cloud computing offers scalable data storage solutions, while edge computing processes data closer to where it is collected, which also reduces latency and which also enhances real-time data processing capabilities. So in a nutshell, these are the key technologies that are already being used in different smart city projects around the world. So now, having understood these key technologies, let's just focus on one technology, which is Internet of Things, IoT. So let's just explore how IoT technology functions within smart cities, focusing on its key features and the outcomes they enable. So here there are certain unique set of capabilities and benefits which are possible by using IoT technologies. So one is connect. So IoT platforms can connect any device, integrating them under a unified data model. So this allows all city systems to communicate seamlessly. So for example, data coming from a smart meter in a building and data coming from a traffic sensors at the street, it can be managed using a unified data model. The data from those sensors can be captured continuously by using these kind of IoT platforms or technologies. The second benefit is analyze. So analyze means the capability to perform various types of analytics, including real-time streaming, correlation, aggregation, and also predictive analytics. So this also enhances our information processing, which also supported by more informed decision making. The third benefit is visualize. So visualization is also a key aspect. So for example, various dashboards can be built easily to display key performance indicators, KPIs, also events, alarms, and notifications. So that also helps city authorities to first of all uh, monitor any specific scenario and also take action as soon as something occurs. So these kind of dashboards also helps them. And this kind of visualization is usually done in a no user-friendly manner. So it also makes data accessible to everyone, to every department. So each department can have their own dashboards where they can monitor, they can analyze the data specific to that particular department. The next advantage or capability is predict. So by utilizing machine learning and AI tools, we can also gain deeper insights and make accurate predictions based on the collected data. And the last one is execute. So insights are actioned upon in an automated way, which also influences business processes. So this can also include integration with, for example, enterprise applications to ensure that decisions are implemented effectively. So if there is any alarm, the insight from that alarm can be sent to a specific enterprise application in a seamless way. So these are the unique set of capabilities and benefits, but the advantage is that when combined, these functionalities helps us to achieve significant benefits. So for example, one is energy efficiency, so we can reduce or minimize energy loss. The other one is cost optimization, so we can save cost by optimizing resource allocation, and also the enhancing customer experiences. So we can improve services and interactions, directly impacting the quality of life for residents. So as I mentioned, together, these elements of IoT, they not only streamline city operations, but also contribute to making urban areas more sustainable and responsive to the needs of their citizens. And that's why these kind of IoT platforms are really important and really crucial in enabling these functionalities in smart city projects. So in this slide, I mentioned about the different capabilities and unique set of benefits provided by IoT. Here, let's just discuss how IoT platforms, for example, Cumulocity, allows us enabling these features that I discussed in the previous slide. So Cumulocity platform or IoT platforms, first of all, provide robust device connectivity. So if we talk about Cumulocity, Cumulocity supports a wide array of protocols like MQTT, OPC UA, Modbus, and many others. And this diversity allows businesses to easily connect and manage their devices and assets from using a single platform. So that really helps streamlining operations across the specific department. The other advantage is device management. So Cumulocity offers comprehensive tools, for example, for remote management, configuration, and also sending updates. So this also ensures that all connected devices are maintained efficiently, they operate at peak performance, and also experience minimal or zero downtime, which is also quite crucial. Another advantage is streaming analytics. So with built-in tools for real-time analytics, uh, or real-time data analysis, Cumulocity platform enables immediate responses to emerging patterns and conditions. And as I mentioned, this capability is also crucial for dynamic urban environments where conditions change rapidly and the authorities need to take action swiftly as soon as any occurrence of any issue. Another advantage is application, which you can see on the top layer. So application enablement. So Cumulocity provides a flexible environment for developing custom applications, which can include microservices or web applications. So these kind of features are also vital for cities looking to tailor solutions to their unique needs. So as I mentioned, every department can create their own dashboards which are solving their specific needs. And that really helps integrating seamlessly with existing processes and enhancing overall urban management. And the last, which is also one of the biggest advantages, flexible deployment. So Cumulocity can be deployed, for example, both on the cloud and at the edge. So this flexibility also allows for scalable solutions that meet the specific needs of urban environments. And this is really important because it ensures data processing and application executions are as close to the data source. So together, as I mentioned, these capabilities of such IoT platforms not only support, but also enhance the key features of IoT in smart cities. So this was about the IoT platforms like Cumulocity. How can they benefit or can they enhance the functionalities of smart city projects? And now in this part, we move into the practical applications of IoT in smart cities. So here I would like to show some specific use cases where platforms like Cumulocity can play a critical role. So here, one compelling example is waste bin monitoring. So this scenario basically demonstrates how IoT can streamline city services and how it can also enhance operational efficiency. So as you can see on this slide, we see a screenshot or an image of the Cumulocity platform, which is managing a smart waste management systems. So as you can see here, the platform displays various data points, such as waste bin location on the map, knowing exactly where each bin is located throughout the city. Also the fill level, which shows the or monitoring how full each bin is in real time. What is exactly the status of that particular fill level of that bin. You can also see other things or other details on this dashboard. For example, bin capacity, which allows us understanding the maximum capacity of each bin. Similarly, scheduled garbage collection, for example, coordinating collection times based on fill levels to optimize routes and timing. That can also help save time for the authorities. That can also help save resources, for example, fuel by that particular department or authority. And similarly, you can also see alarms to alerts like fill level threshold exceeded. So these kind of notification alarms, they can also notify management immediately if a bin needs urgent attention. So this use case illustrates how integrating IoT in city infrastructure can lead to more effective resource management. It can also reduce operational cost, as I mentioned, and in the end, in a nutshell, it can improve the urban environment also. So in this way, city authorities, as I mentioned, can not only monitor, but also proactively manage their services, ensuring efficiency and sustainability. So this was the example about the waste bin. Now let's move to another practical application of IoT in smart city called fleet management. So here on this slide, which shows how Cumulocity platform optimizes fleet operations through a structured flow of data and intelligent analysis. So here on top, you can see this workflow diagram. So here's how it works. So first of all, telematics device installation. So vehicles are equipped with telematics devices that are configured to meet the specific tracking needs of the project. Then data transmission. So data from each vehicle is sent wirelessly to the Cumulocity IoT cloud, which also ensures continuous communication from the devices. And the third part is data analysis. So driving and vehicle parameters are analyzed in context, which also provides insights into vehicle performance and driver behavior. So these kind of solutions have a great or significant benefits. So for example, you can see many benefits. So one is, for example, real-time status updates. So we can keep track of each vehicle in the fleet instantly. Another one is time tracking. So we can monitor duration of trips and stops. Another one is customizable reports. So we can tailor reports to specific requirements, which also enhances decision making. Then one advantage could be auto alarm activation. So we can receive alerts for predefined events or thresholds as soon as anything happens. And similarly, trip rating and benchmarking. So we can also assess the efficiency of trips and compare performances across the fleet. So as I mentioned, there are many advantages we can achieve by enabling these kind of fleet managements supported by an IoT platform. And this is really an interesting use case because that highlights how IoT can transform fleet management, which in turn enhances operational efficiency, reducing cost, and also improve service quality in urban transportation. So now let's now introduce another vital application of IoT in smart cities, so which is called fatigue monitoring or workforce management. So here, platforms like Cumulocity can play a crucial role in enhancing workplace safety and health management. So here, the platform can display, for example, health-related details. So it can track and record vital health metrics such as heart rate, SpO2 levels of an employee. It can also show location monitoring, so we can keep track of the employee's location in real time. And as you can see here in this screenshot, it can also show key event and alarms. So alerts can be generated for critical situations, such as when a worker enters an unauthorized area or experiences a fall or an accident. So this is also very important because it demonstrates how real-time events by such IoT platform, they can significantly enhance employee safety and operational compliance in urban work environments. Then one more application or scenario use case would be the visual monitoring capabilities, specifically through the use of digital twins in a large factory settings. So here again, you can see a screenshot from an IoT platform like Cumulocity. And in this dashboard, you can see, first of all, factory layout. So it displays an image of a factory with labeled components, such as the shredder site, C&D treatment areas, and so on. Then you can also see devices at risk. So it can list all the devices with their IDs, names, alarm statuses, which also highlights those with critical alarms. And then you can also see alarm lists, so detailed specific alarms like inlet flow threshold exceeded, which can provide immediate alerts to potential issues. So this use case also showcases how IoT platform can be used for comprehensive visual monitoring and management. And this is also quite crucial because it allows for real-time oversight of physical assets and operational conditions, which in turn enhances responsiveness and preventive maintenance in such complex industrial environments. So here I mentioned some of the use cases that can be enabled by IoT platforms like Cumulocity. And now in this part, let's shift our focus to real world applications of IoT and smart cities. So maybe let me just quickly see if there are any questions. If not, we can also discuss it later. So yeah, I can see there are no questions. So yeah, as I mentioned, now let's shift our focus to real world applications of IoT in smart cities globally. And here I would like to show or present some case studies who are actually using platforms like Cumulocity in enhancing their smart city operations. So the first case study I would like to highlight is the achievement of Telstra, which is Australia's leading telecommunication company. So here the objective was that Telstra aimed to enhance connectivity across Australia using its robust IoT network, providing solutions that solve actual customer issues. And as part of the solution, what they did, they employed Cumulocity IoT platform to manage a multi-tenant system. And the setup basically enhanced device control. It offered clear insights via intuitive dashboards, and it also ensured secure data storage. And that basically allowed them for easy integration and existing business applications with existing business applications. And the benefit that they observed by using Cumulocity platform is Cumulocity allowed them improving data visibility, first of all. It enabled faster decision making by using these kind of dashboards. And it also reduced cost, which helped boosting productivity and customer experiences. And here in this part, you can see a screenshot of the Cumulocity platform used by Telstra. So here you can see the intuitive dashboards that provide interactive access to various KPIs across different sectors, such as smart agriculture, waste management, smart parking, and also smart lighting. So as you can see, these kind of dashboard, it allowed for real-time monitoring and management and really helped making it easier for the company to optimize operations, respond quickly to changes because they could see all the key performance indicators on one single dashboard. So it really helped responding them quickly to changes. And overall, it also enhanced the overall efficiency in managing such urban infrastructure. So this was one example by Telstra. And now in this slide, we explore another use case or another case study, which is using the Cumulocity platform by Saudi Aramco, which focuses on their city command and control capabilities. So I haven't personally worked on this project, but I really like this one. So this screenshot here shows how the platform's dashboards are used for managing various urban systems. For example, we can see detailed KPIs for smart power, which can include power meters, sector-wise energy consumption, as well as energy outage times. So as you can see, this really enables effective monitoring and management of the city's energy usage. Additionally, the dashboard for smart parking. This is also quite interesting because it displays maps and real-time data on parking by zone labels and occupancy rates. And similarly, you can also see smart irrigation maps, so which also includes irrigation schedules and weather information, which also aid in efficient water management. So what I wanted to mention, so these kind of intuitive dashboards, they provide Saudi Aramco with critical insights, and it allowed them to optimize and streamline city operations through real-time data interaction. So this was the case study from Saudi Aramco, and now in this slide, we delve into STW's innovative approach to real-time pollution monitoring. So STW, Sensor Technik Wiedemann, is a German industrial vehicle telemetry specialist. And here the objective was they created a flexible ecosystem using customizable components to quickly develop tailored solution for both commercial and government sectors. And here their aim was to enhance time to market and time to value. So for that purpose, they implemented a rebranded Cumulocity IoT-based service that integrated sensors, machines, and also stakeholders. And the setup basically featured real-time condition monitoring at the local edge and also comprehensive device and application management on the cloud IoT platform. So here the solution basically enabled STW to deliver IoT solutions rapidly within weeks, and that really offered functionalities which were previously not possible. And one of the biggest achievement for them was it really helped decreasing emissions from retrofitted buses to meet Euro 6 standards, and it maintained constant monitoring of pollution charges. So as I mentioned, this is the screenshot of the Cumulocity platform utilized by STW for real-time pollution monitoring and vehicle tracking. And here, this dashboard, you can see that it provides interactive access to essential KPIs that really helped monitoring and managing pollution and vehicle performance in real time. So here you can observe in this screenshot the map detailing the routes taken by the vehicles, and alongside there is a time series graph that displays various vehicle properties such as speed and throttle. So what I wanted to share here that this kind of intuitive interface enabled by IoT platforms, they really allow for effective monitoring and immediate decision making, which enhances in the end environmental compliance and operational efficiency. So now, in the previous case studies, we have seen how Cumulocity IoT platform impacts various smart city projects. For example, Telstra, Saudi Aramco, and also STW. And now let's explore another innovative concept which I mentioned in the beginning, urban digital twins. So although Cumulocity isn't being used here in these mentioned projects, which I'm going to show, but the same key technologies we discussed earlier, like IoT, geographic information systems, artificial intelligence, they come together to create real-time replicas of city objects. So these digital twins, they are really beneficial because they allow for detailed simulations and what-if scenarios, which provide cities with powerful tools and planning and decision makings. So I want to show here some use case studies which showcase how the urban digital twins are being utilized in different smart city projects. So this screenshot here, it shows the urban digital twin of the city of Munich, where I used to work earlier. So on the left-hand side, you can see a current digital replica of the city that includes detailed models of buildings, street with accurate lanes. For example, here you can see that this street is used by car. There are also some other streets which have lanes which are used for parking and so on. And it also includes detailed models for vegetation. So this is basically the real-time or digital replica of the city in the current state. And then the real-time traffic sensors, which are integrated into this model, they provide updates on traffic density at different times throughout the day, which also offers a clear depiction of daily traffic flow. For example, if this junction is congested in the morning hours and free in the afternoon hours, and so on. So these kind of analysis can be performed by having or by embedding the real-time traffic sensor data enabled by IoT platforms. So this is the current scenario for the digital replica. And on the right-hand side, they show a planned version of the same area by the city authorities. So if you notice on the right-hand side, they propose to replace one car lane with a bicycle lane. So utilizing the real-time data that I mentioned earlier from the current traffic conditions, they now plan to conduct a what-if analysis. So this analysis basically will explore potential changes in traffic flow and congestion due to the new bicycle lane. So that is really helping City of Munich uh, further to predict and plan for the impact of these changes effectively. So this is one of the biggest advantages of using such kind of urban digital twin, which integrates sensor data, GIS data, the 3D models, and so on. So this was the example of city of Munich. And another example I would like to share is from the city of Helsinki, where I also worked. So for example, here in this screenshot, you can see the urban digital twin of city of Helsinki. And now in this case, it is specifically designed for energy demand estimation. So here you can see that this digital twin utilizes real-time data from smart meters and sensors, which visualizes energy consumption and demand directly on the digital models of the city buildings. You can see here this kind of visualization. This is really aiding energy planners by providing a clear and accurate picture of energy usage patterns across different areas. So you can see which part of the city is consuming, which have the high energy demand, and it is really helping them to identify higher demand zones in the city area, optimizing energy distribution accordingly, and also plan for the future energy needs more effectively. So this is also one of the interesting example of digital twins for cities, because these kind of tools are really essential for enhancing the city's energy management strategies and ensuring sustainable energy supplies. So these are some of the examples that I showcased, which show that how IoT technologies or digital twins are being used by smart city projects to really increase their efficiencies and operations. And now in this part, I would like to share some common challenges that we face in implementing these kind of smart city technologies and what should be the right strategies to overcome. So for example, this is the list for the challenges in implementing smart city technologies. So here, one of the biggest challenges is cyber security. So what happens as connectivity increases, so does the risk of cyber attacks that can compromise personal and municipal data. So one way to counter this is by implementing state-of-the-art cybersecurity measures. For example, by conducting regular audits, by promoting the development of secure IoT devices, and so on. Another challenge is privacy concern. So because we are collecting data, so this extensive data collection necessary for smart city, it also raises questions about surveillance and personal privacy. And to address these concerns, we also enforce, or we should enforce, strict data protection laws. We should utilize data anonymization techniques and also maintain transparent policies. Another challenge is digital divide. So there's always a risk that some citizens may be left behind without access to the digital benefits of smart cities. So we can bridge this kind of divide by expanding digital infrastructure, which can provide affordable internet access, and which can also support digital literacy programs to ensure equitable benefits for all. And the last but not the least is integration. So specifically IoT device integration. So for example, managing the complexity and scalability of IoT devices, it can also present challenges such as interoperability and maintenance. If the devices can understand different kind of data, if they can be managed in a standardized way. So the solution for this is adopting a robust IoT platform because it can help managing device networks more efficiently, improving interoperability, and simplifying maintenance and also updates to the devices. So these are some of the challenges that I wanted to highlight. And now in this part, which is the last part of my presentation, I would like to show several emerging trends which are also promising to further enhance our smart city technologies. So here I have highlighted some of the emerging trends or future trends. So one of such emerging trends is integration of IoT with artificial intelligence, or the term, which is a new term, artificial intelligence of things, AIoT. So here, by using self-learning algorithms, for example, we can significantly enhance the efficiency of city systems. So one example could be adaptive street lighting, which can dynamically adjust its brightness based on the presence of pedestrians and vehicles. So in that way, that can not only save energy, but also improves urban safety. Similarly, this technology or AIoT combination, it can also allow for smart water management. So for example, adjusting usage in real time based on weather conditions and consumption patterns. So this is really quite upcoming and quite beneficial. It has a huge benefits if these smart or self-learning algorithms can be combined with the IoT data. Another emerging trend is 5G. So 5G technology is highly crucial for supporting the high speed or low latency transmission of massive amounts of data across smart city networks. So this also allows innovations like real-time traffic management systems, where traffic signals adapt instantly to changing flow conditions. And another example could be 5G can facilitate more responsive emergency services, enabling them to react swiftly to incidents as they happen. Then the third emerging trend that I observe is autonomous vehicles and mobility, which is also enabled by 5G technology. So self-driving buses and vehicles, they are being piloted in many cities, which are designed to reduce traffic congestion and decrease urban emissions. So these kind of vehicles also integrate seamlessly with smart traffic systems, and which can also enhance public transport safety and efficiency. And these autonomous vehicles, they also allows for a new era of mobility, where, for example, autonomous taxis and shuttles become commonplace in urban transport systems. Because we talked about security and cybersecurity, so I would also like to highlight blockchain, which enables transparency and security. So here, cities like Dubai are really doing great work. So in cities like Dubai, blockchain technology is being adopted to secure and streamline municipal processes. So, for example, from recording property transactions to automating license renewals, these kind of blockchain technologies, it enhances the integrity and transparency of public records. And it also helps preventing fraud and increasing trust between city authorities and citizens. And that makes bureaucratic processes more transparent and accountable. And last but not the least is mixed reality. So technologies like augmented reality and virtual reality, they are really transforming urban planning by allowing planners and engineers to visualize and interact with architectural and infrastructural changes before they are made. So these technologies, the unique thing is they offer a virtual walkthrough of planned developments, and that really provides a tangible feel for new projects. So for example, using VR glasses, you can actually see how this particular district would look like 20 years ahead of time. And this they also facilitate community involvement, in my opinion, by enabling residents to understand and contribute to urban development initiatives. So that also in turn enhances public engagement and feedback. So citizens or residents, they can provide their feedback about the planned scenarios by the urban authorities. So this is also quite useful and quite upcoming and quite a powerful combination of using such kind of mixed reality technologies. So, in a nutshell, yeah, these advancements they really represent the forefront of smart city innovation, according to me, and they are really driving us toward more efficient, secure, and intelligent urban environments. So yeah, this was my last slide, and as I conclude, we explored today the concept of smart cities and the crucial role IoT plays in enforcing them. And we also saw real world applications, we also discussed challenges, and in the end, we also looked at the future trends that promise to further urban living. And as we move forward, I'm really pretty sure these innovations will continue to make our cities smarter, safer, and more sustainable. So, yeah, with this, I end my presentation. So, I think if there are no questions, then maybe we can end the session. Shruk, are you there?
Yes,
Yeah.
but I don't know why they missed the chance to ask you a question. Okay, I think yes, we can end it for the
Mhm.
record. It's already there in the Blackboard Ultra. You can find it in the course in the Blackboard. Maybe
Mhm.
I can share. I can share the way with you after the session, inshallah.
Super.
For the session, I would like to thank you again. It's really amazing one, and we really enjoyed it. And I'm pretty sure they are getting a lot of value out of this. And thanks again to joining us.
Yeah. Thank you so much.
And thanks for your content, for your presentation and everything. Thanks a lot, Doctor.
Yeah. Thank you. Have a nice evening. Bye bye.
Thank you. Bye.